Long before the Megalodon became the symbol of ultimate oceanic dominance, the seas were ruled by predators far stranger and far less understood. This was an era before sharks, before jaws hardened with teeth, before skeletons defined power in the water. The ancient oceans were not empty or primitive. They were full of life that followed completely different evolutionary rules. In these early seas, dominance did not require bones. Many of the most successful predators had no skeletons at all. Their bodies were soft, flexible, and often transparent, blending perfectly with the surrounding water. Fossil records rarely preserve such creatures, which is why their reign remains largely invisible to us today. Yet absence of evidence does not mean absence of power. These early ocean predators relied on strategies that modern hunters rarely use. Instead of chasing prey with speed or tearing it apart with teeth, they surrounded, paralyzed, dissolved, or absorbed their victims whole. Some used venom delivered through soft appendages. Others trapped prey inside living membranes, breaking them down chemically rather than mechanically. In a world without hard armor or sharp jaws, biology favored precision and efficiency over brute force. Many of these creatures had no eyes, yet they were not blind in the way humans understand vision. They detected movement through pressure changes in the water. They sensed electrical signals, vibrations, and chemical trails left behind by other organisms. In complete darkness, they hunted with perfect accuracy. Vision was optional. Awareness was everything. During this period, the oceans themselves were different. Oxygen levels fluctuated. Water chemistry changed constantly. Massive evolutionary experiments unfolded beneath the surface, most of them erased by time. Entire lineages rose, dominated, and vanished without leaving a single fossilized bone behind. What we know today comes from rare impressions in ancient sediments, chemical traces in rock, and comparisons with the few soft-bodied predators that still exist. Creatures similar to modern jellyfish, siphonophores, and deep-sea organisms hint at what once ruled these waters. Some scientists believe these ancient predators could reach enormous sizes, far larger than their modern descendants. Without rigid skeletons to limit growth, size was constrained only by energy availability and environmental stability. This was not a chaotic world. It was a balanced system where soft-bodied giants held the top of the food chain for millions of years. They thrived not because they were fragile, but because they were perfectly adapted to their environment. Their bodies left no trace, but their influence shaped everything that came after. Eventually, the ocean began to change. New competitors emerged. Creatures with cartilage and bone appeared, bringing jaws, teeth, and structural strength into an ecosystem that had never faced such threats before. The age of soft dominion was approaching its end, but its disappearance would leave behind one of evolution's greatest mysteries. Before the Megalodon, before sharks, before bones ruled the sea, the ocean belonged to monsters that history almost forgot. For millions of years, soft-bodied predators remained at the top of the oceanic food chain, not because they were simple, but because evolution had refined them into perfect biological weapons. Their bodies were not weak versions of future animals. They were optimized for a world where hardness was unnecessary and sometimes even a disadvantage. Without bones, these creatures could compress, expand, and reshape themselves to survive pressure changes that would crush rigid bodies. They could pass through narrow spaces, envelop prey larger than themselves, and withstand impacts by dispersing force through soft tissue. In the deep ocean, flexibility meant survival. The lack of skeletons also allowed for unusual forms of intelligence and coordination. Some ancient predators are believed to have functioned as distributed organisms rather than single bodies. Colonies of interconnected individuals moved and hunted as one, sharing sensory information across living networks. In such systems, there was no single brain, but awareness existed everywhere at once. Evidence of these creatures does not appear as bones or teeth, but as disturbances in ancient sediment layers and chemical signatures locked inside rock. Certain patterns suggest massive biological activity that cannot be explained by known skeletal animals. These traces hint at ecosystems dominated by organisms that left almost nothing behind when they died. Evolution during this period followed paths that modern life rarely explores. Speed was not always necessary. Armor was irrelevant. Many predators relied on patience, drifting motionless for hours or days until prey entered their reach. Others used bioluminescence not as light, but as deception, mimicking harmless organisms to lure victims closer. Energy efficiency was critical. Soft-bodied giants required less material investment to grow large, allowing them to dominate vast territories with minimal metabolic cost. In a stable ocean, this strategy worked perfectly. Nothing needed to change, so nothing did. But evolution never stops experimenting. As oxygen levels slowly increased and environmental conditions shifted, new life forms emerged that challenged the soft rulers of the sea. Cartilage appeared, followed by early skeletal structures. Jaws became stronger. Muscles attached to rigid frames allowed faster movement and more aggressive hunting styles. These changes did not cause immediate extinction. For a long time, both worlds coexisted. Soft-bodied predators adapted, retreated deeper, or specialized further. But the balance had shifted. What once was optimal began to carry hidden weaknesses. Hard bodies fossilized, soft bodies vanished. As the ages passed, the history of the oceans began to rewrite itself. Creatures with bones left records of their existence, while those without were slowly erased from the visible past. What survived in stone became the official story of life, while entire dominant lineages faded into silence. The ocean did not forget them, it simply buried them in a way we were never meant to see. And as skeleton-based predators continued to rise, they inherited a world already shaped by monsters whose names we will never know. The transformation of the ocean did not happen in a single moment, and it did not arrive as a violent catastrophe. There was no sudden apocalypse that wiped soft-bodied giants from existence. Instead, the change was quiet, gradual, and far more effective. Evolution rewrote the rules of survival from the inside. As geological time passed, ocean chemistry shifted, oxygen levels stabilized, and new ecological pressures emerged. In this changing environment, rigidity became an advantage. Early organisms began developing internal support structures made of cartilage and, later, bone. These structures allowed muscles to generate greater force and maintain speed over longer distances. For the first time, predators could chase rather than wait. Jaws evolved not merely as tools for feeding, but as instruments of dominance. Teeth allowed predators to damage, tear, and kill quickly, reducing the energy cost of hunting. Skeletons provided protection against attacks that would have once been fatal. In this new evolutionary arms race, soft bodies were no longer invulnerable. Yet the ancient rulers did not disappear immediately. Many adapted by retreating into deeper waters, where pressure and darkness still favored flexibility over strength. Others became more specialized, evolving stronger toxins, faster reactions, or more complex sensory systems. For millions of years, two evolutionary worlds coexisted in the same ocean. But coexistence does not mean equality. Hard-bodied predators left traces of their success. Every tooth, every bone, every fragment preserved in sediment reinforced their presence in the fossil record. Soft-bodied predators, no matter how dominant, left almost nothing. As generations passed, the historical imbalance grew wider. Over time, skeletal predators began to reshape entire ecosystems. Their feeding behaviors altered food chains. Their remains changed sediment composition. Their survival strategies became the foundation of modern marine life. Evolution favored what could endure physical stress and leave evidence behind. This was the moment when sharks began their ascent. Early sharks combined flexibility with structure, using cartilage instead of bone to remain light and fast while still gaining mechanical power. They inherited lessons from both evolutionary paths, becoming efficient, adaptable, and relentless. Compared to them, the ancient soft giants were increasingly outmatched. The ocean did not choose violence, it chose efficiency. As millions of years passed, the balance tipped permanently. The deep sea became a refuge rather than a throne. Soft-bodied predators faded from dominance, not because they failed, but because the world they were built for no longer existed. What survived became smaller, stranger, and hidden. What vanished took its history with it. By the time the Megalodon's ancestors would one day appear, the ocean had already forgotten most of its former kings. Or so it seemed. The disappearance of soft-bodied ocean predators did not mark their absolute end. It marked their withdrawal. As skeletal hunters claimed the surface and midwaters, the deepest regions of the ocean remained largely untouched by this evolutionary takeover. Pressure increased, light vanished, temperatures dropped. In these conditions, rigidity once again became a weakness. The deep sea preserved an ancient logic. Even today, much of the ocean remains unexplored. Vast areas of the seafloor have never been directly observed, and most deep-sea species are known from brief encounters, damaged specimens, or indirect evidence. What survives in these depths often resembles the distant past, more than the modern surface world. Many existing organisms echo the design principles of ancient soft-bodied predators. They are transparent, gelatinous, and flexible. They lack complex skeletons and rely on pressure resistance, chemical sensing, and minimal energy use. Some species appear to function less like individual animals and more like living systems, spreading across large volumes of water with no clear boundaries. Deep-sea siphonophores, giant jellyfish, and unknown gelatinous forms demonstrate that size without bones is still possible. Some recorded specimens exceed known limits, appearing only briefly before disintegrating or vanishing back into darkness. Their true scale and behavior remain uncertain, because observation itself alters their fragile structure. Modern technology struggles in this environment. Submersibles illuminate what was never meant to be seen. Cameras disturb chemical gradients and pressure balances. Soft-bodied organisms collapse, dissolve, or escape detection entirely. In many cases, the act of observing destroys the evidence. Chemical anomalies detected in deep ocean water columns suggest biological activity that cannot be fully explained by known species. Massive carbon movement, unexplained energy flows, and sudden biological signatures appear and disappear without leaving physical traces. These signals resemble the footprints of ecosystems that function without permanence. From an evolutionary perspective, extinction is not always final. Sometimes it is a change of strategy. Retreat can be survival. In the deep ocean, time moves differently, and pressure preserves forms that surface evolution abandoned long ago. The monsters of the ancient seas may not have vanished. They may have simply returned to the environment that shaped them in the first place. A world without light, without witnesses, without bones to remember them. Long before the Megalodon, the ocean learned how to hide its most successful predators. And in the depths, it may still be hiding them now. The history of life in the ocean is not written by dominance alone. It is written by what can survive time, pressure, and stone. For millions of years, evolution favored bodies that could harden, fossilize, and remain visible long after death. What we call the history of the oceans is largely the history of skeletons. Teeth, bones, and armor became the language through which life explained itself to the future. But this record is incomplete. Soft-bodied predators ruled vast stretches of evolutionary time without leaving monuments behind. They shaped ecosystems, controlled food chains, and defined survival long before sharks and giants like the Megalodon appeared. Their disappearance from the fossil record did not mean they failed. It meant they were built for a world that does not preserve memories. What we study today is not the full story of evolution. It is only the part that survived burial. The deep ocean remains the closest thing to Earth's past still alive. In its darkness, ancient rules continue to operate. Flexibility over rigidity, efficiency over force, silence over visibility. Life there does not need to be remembered. It only needs to endure. As technology advances, we will continue to glimpse fragments of this hidden world. Shapes without structure, movements without explanation, signals without bodies. Each discovery will raise new questions, not because the ocean is mysterious by nature, but because it was never designed to reveal everything. The monsters before the Megalodon were not erased by extinction alone. They were erased by time, by softness, and by the limits of human observation. What came after inherited a quieter ocean, already shaped by creatures whose names we will never know. And what still exists below reminds us of a simple truth. The most successful predators are not always the ones we remember. If you want to explore the forgotten chapters of evolution, the hidden logic of nature, and the worlds that existed long before our own, subscribe to the channel and stay with us. There are many stories the past did not leave behind. We are here to search for them.